All right. Welcome, everyone, to week 4 of the Phoenix Book Club Hangout, or as Garrett has sometimes started calling it, the Late Night Coders Club.
Yeah.
I think that's a pretty good name. All right, so this week we're talking about Chapter 5, but before we get kicked off, we'll go ahead and start with introductions. So, Zach, do you want to start us off?
Sure. I'm Zach. I enjoy Phoenix and Elixir. I work at MX with most of the people on this call, doing mostly Ruby stuff there.
Sweet. John, you want to go?
Sure. I am John. I also work at MX. Okay, my mic's on. And I've been enjoying dabbling with Phoenix and kind of, now that we're kind of getting later in the book, there's a lot more, seems there's a lot more discovery that keeps happening. It makes things even more exciting than just the first few chapters. And grateful to be part of the Late Night Coders Club.
All right, Garrett, you're up.
Hi, I'm Garrett. Also work at MX. Late night Coder Club member for a long time now. Just enjoying the breath of fresh air that that Phoenix has been so far. So that's it.
Sweet. Dave, you want to go?
Yeah, I'm Dave Hackett. I work at Master Control. I got roped into this by posting something on Twitter about the number of commits in the year that Mike had done so far. It turned out to be 666. I thought that was kind of ominous. Yeah, and then he asked, hey, do you want to be part of this group? So I got roped into it, which I'm very glad. It's been a lot of fun. So yeah, I'm really enjoying Elixir and Phoenix both.
Sweet. Chris, why don't you give a quick intro?
All right. I don't know if I tried to upload a custom image, but it looks crazy. Yeah, so I created Phoenix and co-authored the book. So been having a lot of fun and happy to be on with y'all.
Sweet. I'm Mike. My late night coder club activity is to rope all my friends into jumping on video chats and talking with me about nerdy stuff so that I can learn more and more quickly. So probably don't become my friend on the internet if you like to spend your nights doing something else. But yeah, so tonight we're going to be talking about Chapter 5. Before we jump in on Chapter 5, we're going to do a quick round the horn on anyone who has a follow-up item from a previous week. And I'll kick us off. I have a good one here. So I had a little gripe last week about Ecto. So my gripe was basically like this. If I start up my app, let me just grab this thing. So I'm going to make a change set here real quick. So I'll just alias my model and alias the repo. And then if I make a change set like this, I can see that it is an invalid change set right here. It says errors, username can't be blank, right? And if I try to pipe that into repo insert, I get back very sensibly this tuple of error and the change set that failed. And I really liked that. But then I made a unique index on my username field. And if I tried to violate that unique index, I was really sad that this threw an error instead of returning me something that I could pattern match on. So I kind of griped about it last week. And then this week, when I looked into it a little bit, it turns out that there's this really super helpful error message that says, if you would like to convert this constraint into an error, please call unique constraint in your change set. And then I felt like a jerk and looked this up, and it turns out that this unique constraint thing in the change set is actually super cool because it says right here, it works by relying on the database check. So this isn't even like a Rails validation for uniqueness. This actually lets the database do the check for you, which is really neat. And so it turns out that all I had to do was just in my user change set. Right here, just tack on a unique constraint username, and then if I rerun that same command, we'll just copy and paste this real quick. Then I get back, aliases. Yep, user and repo. Now I get back something that I can easily pattern match on. So, so I just wanted to follow that up because I griped about it, but then when I dug into it, of course, there was a really great error message, and it turned out to be no big deal, and actually a really cool feature that I probably wouldn't have found otherwise. And then similarly along those lines, I also asked the question last week about in your router if there was a good way to branch on things other than the path, like specifically headers, because there's a few APIs that I maintain at work where we branch on the header version. We look at a header to figure out which version of the repo they're trying to access, and we branch based on that. And that also turned out to have a really nice, I won't show it, but if you look at the docs under Phoenix, the scope call actually takes a second argument, and you can pass it a whole bunch of other things that you can pattern match on different parts of the connection that's getting passed through, including things like headers. So
Let's
those are
go ahead and show us that. I want to see that. Let's talk about it.
Okay. Let's do this. Screen sharing exception. So where I found that was here, and then the call to scope right here. So it has this, and then it also has these other supported options. And so a string containing the path scope, you can like kind of name this scope, alias host. So right here is where you can match based on like the host name that's got requested, private and assigns, and then this other form of it here, path options and list. I'm trying to remember which one of these. Do you remember off the top of your head, Chris, where you would pass in to match on another part of the connection besides host or the assigns?
I didn't think that existed, so that's why I want to see it.
All right.
Did you write the code? Because I was gonna show you how I would do it, but then when you said you figured it out and it was handled in scope, I was like, huh, interesting.
No, so I haven't implemented it yet, so maybe it's not there. Just when I was looking through this list of, let's see, where was it?
You can pass in. You may have thought you can pass in a map of like params and stuff that you want to have placed in the connection, but you can't actually match on it.
Oh, so yeah, this assigns right here. It's not matching on it. That's going to be merged into your connection.
Yeah, because we can't really efficiently match on it. But I can show you how I would do it, and it would go pretty well into maybe this chapter.
Yeah.
You want to see it? That's okay. Because this actually, it's really helpful for people to like understand how Plug works, and it's super simple. So let me figure out how to use Hangouts. Somewhere.
It looks like a green screen with an arrow on it.
Screen share. Okay, is that working?
Yep.
Okay, so what I do. So you have an endpoint, right? This isn't going to be real code, but at the bottom of your endpoint, you plug the router, right?
Yeah.
My app router. So it turns out, the plug contract's super simple. So in your router, what I would do, like you want to route based on different headers in your connection. So what I would make is normal router, but instead of using Phoenix router, this is just going to be like a proxy router, and all it's going to take, it's going to have a call function, take the connection, and do any logic you want. So I'm going to pretend that you have a request header. I don't know what X API version, whatever. And then we can say if it's v1, then I'm going to call my app dot v1 router. Whoa. And then I just did something crazy.
Of course, yeah, I totally wanted to duplicate that 50 times, Ben. Thanks.
Yeah, I do that. That happens to me pretty often. Okay. So we would just intercept this with a normal plug, and then otherwise we would just call our some other what am I going to call it?
Yeah.
Oh, this is bad naming. Let's say we have move
Okay.
your original router would just be renamed to your base router, and then you just proxy to that. Oh, sorry, and these all become calls. Pass a connection for the options, and then this would be your regular router that exists today.
Gotcha.
Each of those would use Phoenix router, and since it's plug all the way down, we can just write simple things that abide by the plug contract. Specific logic we want for this routing, and then still use Phoenix router, but with 3 separate routers instead of 1. So there's the gist of like what you can do with plug. So instead of trying to make the router like accommodate everyone's like individual use case, we decided to say let's just we have this plug contract. So if you want to do something crazy that we don't support with our router, then you just do it in a plug, and you can still proxy back into a Phoenix router.
All right. So is that
makes sense.
Yeah, I'm wondering, is that the same way then that like inside the router, the Phoenix router, when you say pipe through this, pipe through that, in each one of those things looks like they are also a plug pipeline? Is that right?
Yep. Yeah, it's plugs all the way down. So like everything is a plug. So everything is just either a function with two arity or a module with an init and a call that takes a connection and returns it.
And so basically that's kind of is that the kind of go-to move anytime you need to have a branch inside your pipe plug inside of a pipeline of plug? I don't even know what you call those, plugs. But
yeah, so basically yes, and it's going to be plugs all the way down, and you could do, I don't know why you would want to do this, but yeah, I could plug a router in one of my pipelines in my router. That would probably be a terrible idea, but yeah, you can compose these however you want, and then they can branch however they want. You would just want, if you did that, you would want to make sure you halt appropriately, but that's how I would route off of headers today.
sweet.
So like 10 lines of code for you saves us from having to try to support like all these random special matchers. So yep.
Sweet.
Big ups to that. I think that's awesome.
Cool.
All right. Did anyone else have a follow-up item from a previous week? All right. All right, so let's get started then discussing Chapter 5. So Chapter 5 is, it's titled Authenticating Users, but the theme of the chapter to me really seemed like it focused around plug, obviously implementing your own plug, and it also got into a lot of the things that you can do with the connection struct that gets passed through, and kind of what are all the different data fields and what are they commonly used for. Anyone want to start us off with a question from the chapter or something they noticed in the chapter that they want to call out?
I don't really have a question. Just a comment for me is just it's really nice to see authentication done in such a simple way, especially coming from Rails where you have to load like 20 gems just to tie into rack middleware and add all of the base layers just to get to the point where you can authenticate someone, it was so refreshing just to see just a tiny bit of code, just a minimal amount, and it functions the same. It logs someone in, and there's no magic there. It's still clean and it's very concise, but there's just no magic, and I really really enjoyed that.
Yeah, I'll actually piggyback on that. One thing that I really loved, I'll share real quick here. So this wasn't from the chapter, but this is another project I was working on. But I think it highlights something that I really found that I like about Plug, which is this idea of kind of having branches within your Plug pipeline. And the reason it really hit me this week that I really like that is because I have this one endpoint here in this app where basically there's like a couple of routes where the user can authenticate using password, username and password, and then I'm going to issue them a session token. And for all these other routes, they have to use a session token. So however they got that session token, they now have to use it for all these other routes. And when I've had to do this in other languages where there is just kind of a single middleware or something like that, then that middleware ends up having all this branching logic inside of the pieces of the middleware because it has to be like, oh, maybe is this a route that's allowed to use this authentication strategy versus that one? And then, like, am I issuing a token or checking the token? And it always ended up having this branching logic, and it was always a pain to track it back down later. So I really love the fact that here I can be like, oh, just pipe it through this thing, and then inside of this widget controller is where I actually like break out the single sign-on token and would generate them a session token. And then for all of these routes, I can just say, you don't worry about any of that. You just have this little session header auth, and it just looks for that session token in a header. And so that was really nice because then each of those plugs is much simpler. It doesn't have to worry about which route it's in or keep track of which routes should be using which things. You know, the combination of having something that's sort of like a middleware, but it can have branches that happen in that middleware, so it's more like a tree of middleware objects, or in this case, functional plugs. That really stood out to me as something that would be really useful, especially when you get into an app that has a bit more of a history to it, and maybe you change from this authentication strategy to that one in different versions of your API, and just being able to keep those things totally separate and share the behavior where you want to, but keep it separate where you don't want to share it.
I also really liked with pipelines how just the connection struct itself, how it just keeps everything nice and tidy, and it keeps some things lazily tucked away so it doesn't give them to you like the what was it, the cookies out of the box, like it doesn't give that to you, so it gets your request loop as fast as possible unless you want something out of it. But I really just enjoyed that the environment object that we're passing down the pipeline or passing through the pipeline is just, it's so well defined, as opposed to, I mean, it gives you room to do custom things, but as opposed to like rack middleware where we're just kind of a hash where people are bolting things on and off and there's really no, I don't know, I mean, there's a pattern, but it's just like random access, right? Whereas the connection struct really shows, I don't know, that things have been cleaned up, and I could tell that there's just been a lot of thought in that connection struct, and that really made me, it just made me feel like this is like middleware 2.0. It can only be in Elixir, so I don't know, I really enjoyed that.
Anyone else have questions that came up during during this chapter?
Yeah, I'll just piggyback on that. And so one thing that we're trying to move away from with is even calling plug middleware, even though that's the easiest, most simple analogy for people to understand. But it's like for us, it's one level of abstraction, and it's not like middleware. I come from Ruby and Rails, so like rack. Usually, like middleware is something like that sits between like the web server and your application code, right? It's like kind of like apart from your app. So like if you're coming from Ruby or Rails, it's like you got rack middleware, and like most people rarely write rack middleware. Like I worked with a team on Rails apps for 6 years, and I think I was the only one that ever wrote a single rack middleware to do anything. So then you come into your app and you have a router and controllers, but then you have some before action, before filters, which is this other idea. So one of the things that we wanted to do with Phoenix is we have one level of abstraction, that's plug, and it's all functional composition. So we're trying to get away from the term middleware, but I can't find a good alternative that makes it easily identifiable. But it's for us, middleware implies something heavy that's outside of your normal app, whereas plug is just functional composition, and whether you're in the endpoint, in your router, or in your controller, it's all plug all the way down. So.
One other thing I wanted to put a little heart emoji on, so to speak, is in a previous week I had asked the question is there a good way, something similar to rake routes or rake middleware in a Rails app where you can kind of print out, here's everything that's in my middleware, and I had asked if there's a tool for that, and I went on the Elixir Slack group and asked around and didn't really find anything exactly what I was looking for. But obviously, it kind of makes sense because you can have this branching logic, and trying to do a static analysis of that branching logic is pretty infeasible. But what I found really interesting is that the way that the plug macros end up unfolding the code is I had just kind of assumed that it would be I'm going to call this and then check if it's halted, then call this one and check if it's halted, then call this one and check if it's halted, and but it actually calls them, it unwraps into a nested set of calls, and it's doing pattern matching on the connection in between each of the different things you plugged in. And one nice side effect of that is that if you get a backtrace from inside of one of your controllers, you can see each of the plugs, each of those module names, you can see them in the backtrace because each one of those is still part of the call stack for that request. And so that gave me most of what I wanted, which is the ability to, when something goes wrong, quickly know who all was involved in touching this connection object, because maybe one of the things that's wrong is that that connection is in a state I didn't expect, and I need to know how it got into that state. So I really liked the fact, I don't know if that was an optimization decision or whatever, but it's really nice for me as a developer that all of those things stay in the backtrace. They don't kind of get chopped out of the backtrace in the way that it gets invoked. Anyone else have questions from this week?
I don't necessarily have a question, but I had kind of a point out that I thought was interesting. It was very simple, but seemed to be more of a difference is when we were dealing with the views, or specifically dealing with that log out or sign out event. And in our, in the view, in the layout of the app, in fact, I could just pull it up and that'd be easier. Get it. Just do this. So I thought it was really neat that in this layout we have this simple link command that not only links to the logout, but it also gives us the session path, and I have it highlighted right there. But so you get the session path, which has the whole connection and the current user object, and then passing this method actually points directly to that controller in that space to go through the whole route of logging out, running that code, deleting the session, whatever you have it that you had to do, without any extra areas that you had to touch in order to route that to the appropriate places. And the usefulness of this and the simplicity, keeping it at one location, I thought was very nice for me to have, as I'm both learning Phoenix and Elixir.
Yeah, I think that also goes along with last week. Last week there was a comment, as we had kind of been, maybe it was 2 weeks ago in our video chat, when we were talking about the kind of the front end of Phoenix, that one of the big letdowns for some of the people in the group was that it wasn't amazingly better than Rails. It seems that this is something that Rails had actually done a pretty good job with link helpers and things like that, because we were like, everything else that we've touched so far is just seems like 2.0 version, and then the view helpers are very similar to what you find in Rails. So I had one question that came up from me in the text. One second here. So in the section where they're talking about building a plug, let's see. In the anatomy of a plug section. Okay, yeah. So they have this example of a nothing plug, and then they talk about sometimes you sometimes you might need Phoenix to do some heavy lifting to transform options for you. That's the job of the init function. Init happens at compile time. And then just below that it says, because init is often called at compile time, it is the perfect place to validate options and prepare some of the work. So I just was wondering, Chris, if you could provide any clarification on that. Is it always called at compile time, or is it up to the framework to choose?
Yeah, so yeah, it is a little confusing. It's almost, for most people, it's almost always going to be called at compile time. Like when you use a plug macro in the router or a controller or an endpoint, the options that you pass there are compile time options. But if someone can invoke your plug, actually this is a perfect example to piggyback off of the code I just wrote, because it was incorrect. So the code we just wrote, we wrote a router that was just a basic plug that proxied to our Phoenix routers, right?
Mm-hmm.
And the issue that we have here is that this is going to happen at runtime. And we didn't use the plug macro, so these options that we're passing down, if they did need to have some work involved, what we wanted to call, and this is going to get a little verbose, but the correct solution here would have been to pass in the options. Oh, actually, we'd have to call init explicitly ourselves. Otherwise, we were skipping the init process and calling a call directly.
Yeah.
So does that make sense? So that's kind of the difference, and this would be a case where we're foregoing doing this at compile time. But had we plug something, go back up. Had we plugged something in our router, if we were using plug builder, which gives us something here, give it, opt1. This is going to be a compile time thing. That is, this is going to be baked in at compile time. But if we're calling a plug directly with just call, we have to invoke the init ourselves, if that makes sense.
Yeah. So then when you are creating pipelines in your router, do those also get run at compile time?
Yep. Anytime you're using the plug macro, it's going to be compile time.
And the pipeline macro actually calls the plug macro, is that right?
Yeah, it's basically just a way to group a set of plugs together.
Cool. That actually brings up one other question that I had. I was working on another project, and I was going to put something in one of my config Elixir files that tried to parse a JSON file and then kind of expand that into some data that would be part of my application configuration. And I got an error that Poison was not available. And so I just had never thought about this, and this is more of an Elixir thing than Phoenix. But in Elixir, when you're at compile time, can you pretty much just depend on the base language and the standard library, not on like your actual dependencies?
No, so mix might be a special case, but at compile time you have access. Your app is actually started, like even the supervision tree and everything.
Oh, okay.
And you have access to everything. So I'm not sure if mix is a special case though, where mix might run first to load up the environment. So that might be just the only special case there.
Yeah, and that would make sense to me because mix, I mean, the overall, like mix itself is the thing that is managing those dependencies, and so maybe the step for like defining all the configuration has to happen before it actually loads those modules or something like that. So I got around it just by, in my supervisor, I basically said, like, I put the configuration of where the JSON file lived in my config, and then in the top of my supervision tree is where I actually go and pull it out and inflate it and set, and I update my application configuration at that point, which was no big deal for me. But anyway, it was one of those weird things that I just had never really dug into what's available at compile time versus runtime. Anyone else have questions from Chapter 5 or comments?
I didn't have any questions. I thought it was a great chapter, but I don't know if it's just my fat fingers or I wasn't reading closely enough, but I definitely ran into more errors this week than I have in the previous weeks, and so it's been real nice to be able to debug what's going on and try and figure that. Most of the time it's forgetting a do at the end of a method, but I also have been getting some weird errors on, like, when I log in and my user doesn't actually exist. I get some interesting, like, no condition clause evaluated to a true value, which is interesting. And then I also get, like, a wrong type. Passwords need hash. The password and hash need to be strings that I'm getting from my input form. So I don't know. It's been fun to kind of, like, dive in a little bit more and try and figure out what I screwed up, which has been, for me, that's where I find, like, the most value in learning is not when things are going good along the happy path, but when, hey, what happens when things go bad?
I think the hashing issue is my fault for the initial users that you create before we add password hashing are inserted into the database with invalid password hashes. So the plaintext password users will all not work currently. We never went back and fixed those. So yeah, that's probably the cause of that.
Cool. I haven't figured that one out yet, but that's good to know.
So I really liked reading about when we started learning about the anatomy of a plug and just seeing, like, hey, the plug.con, it's got a lot of documentation about it. I didn't get into it, but I thought this is really neat that it wraps up everything really nicely so that you can have this connection information all just in one entity passed around. I really liked that. I also liked how I was able to, I mentioned how in the Slack group, how I couldn't do link with the method of delete, but I was able to do button. Like, it was kind of fun, just kind of stumbling around, saying, oh, well, maybe I can make it a button, and the button works, so maybe I can just use the button as a workaround for right now. But other stuff was really neat, but the error messages that really helped me out were just phenomenal. I love the error messages in both Elixir and Phoenix. They teach me a lot more about, like, hey, you're doing something that maybe this is what you really mean to do. Here's a suggestion, or here's your happy path of how to make this work. It's been really nice.
Yeah, I'll actually piggyback on that one. I was so for a Ruby meetup group that I organized here in the area, we were building. We wanted to make AI clients that played like a game of tic-tac-toe or whatever. So I built a Phoenix app that used channels to manage the state of the game. And one of the mistakes that I made early on was basically when someone was joining the game, I wanted to do a broadcast to everyone in the channel to say, hey, another player just arrived, right? And so I would, like, rebroadcast the state of the game. And when I tried to do a broadcast inside of the registration function in my channel, I got an error message, but the error message was actually, like, the most helpful error message I've ever seen in my life. It just basically said, hey, calling broadcast inside of registration is kind of a bad idea because this registration isn't done yet. We need the return value from your function in order to finish putting this person in the channel, so they would not receive this update. And then they're like, if you want to see a good way to make this work, here's an example. And it was like, you send a message to yourself and catch it in the handle info, and then you do a broadcast from there so that gets processed right after the registration. And that was like, oh my gosh, that level of, like, helpfulness in an error message was mind-blowing to me.
It's like having Stack Overflow built into your framework. It's excellent.
I
was just going to say, yeah, so I wrote that error message. But yeah, I knew that would trip people up, but it's funny that like how much the error messages just like save from having to answer support questions. It's like, why not just like answer it right there, and then you're saving yourself time in the future from having to tell people like, oh, if you really want to do this, here's the right way to do it. So it's paid back, and it's just interesting, and saving my future self time from having to re-explain things, and that's not something I had thought about in the beginning. So it's like you're helping people out, but then also you're saving yourself time in the future from having to repeat yourselves.
Never fear. I'm sure we'll break other things that you haven't thought of yet, Chris.
Well, then open an issue.
Just as you're like cutting new features, how much of your time do you spend just like thinking of like once you have a good design in your mind, how much of the time do you spend coding it, and then how much of the time do you spend writing error messages? Because it seems like you're covering every error message case, and it's really impressive. But I want to know, how does that fall back on you in terms of required time to produce the quality framework that it is?
That's a good question. I know that like I've adopted, so we can all thank Jose for this. Like I adopted his documentation and error message kind of wisdom, and so I think a lot of that is driven by everything that I see in Elixir. So I think if I see an error that's bad, I'll fix it. But then, obviously, we also tell people if you don't understand an error, it's a bug. So then the things that we don't catch, then we make sure to improve the error messages. But I'd say a lot of the time I'll spike out code and then kind of not focus on like thorough documentation or errors. But like always, that's something that's like paramount of importance. So before we actually release anything, I'll go back and make sure it's all tidy.
We've probably talked about error messages on every meetup so far. That has been a hot topic.
I don't think we've had a bad story about error messages yet, actually, on one of these video chats, despite the fact that it comes up every week.
Yet you usually don't want error messages. This is the first language you have where you go, I'm excited to see that error.
All right. Any other questions or comments that came up from Chapter 5 before we jump on to move on with the call? By the way, if I ever ask if people have questions and you don't, just give a thumbs down so I can do like a quick scan here on the bottom. All right, we'll move on then. So let's see. Our normal agenda from here is that we do like a show and tell real quick of any +1 projects that people have done. We are a little bit short on time this week, and I want to give some extra time if people have other questions for Chris. This is mostly selfish because I have some extra questions for Chris. But if anyone else has a different question for Chris, they can jump in front of me in line.
I was going to say I didn't get a +1 project in this week because of Hacktoberfest. Got to get my 4 pull requests in from a T-shirt, so that was my work this week. I got them, by the way. Got them all in.
I can't believe how hard I worked for a T-shirt. All right, so here's a couple of questions that I had for you, Chris. So the first one I'm hoping is pretty fast one to answer. One thing that came up for me when we were talking about the way you define ecto model and changeset is it seemed odd to me that you defined a virtual password attribute. It just seemed odd to me that for the same reasons that you would want to have some of your validations be able to come in kind of from different use cases, that you would want to have some attributes only defined in certain use cases. And so I'm wondering if there's been any discussion, or if it's possible maybe right now to say, hey, instead of defining a virtual attribute on my model, can I actually just define that virtual attribute for the context of a given change set? And that way, that password would only exist for registration type calls, and it wouldn't exist at all for like updates or other things like that.
That's a good question. So the only thing, so right now there's no way to do that, and the tricky thing there is when you define a field in your schema and you cast that in your change set, we do the type conversion for you. So the issue is if you said let's not do a virtual attribute and let's just have this chain set take in a key, then we're gonna miss type conversion right away. So that's not something. I mean, that's not something that the Ecto supports now. And I'm trying to think of a use case where you could split those fields up, but I can't think of a good case right now. So I think the answer is simple for now. Is like we don't support it, so add virtual attributes as you need them. But we definitely do promote breakout as many chain sets as possible. So I do see what you're saying with we're promoting this functional composition of chain sets, but then we're ending up with a big bag of fields on our model. But I think I mean my thought is it's probably fine. Like I don't know that if you get in a case where you have so many virtual attributes that it's overwhelming and disjointed, it probably means you need another model. But I could be wrong, so it's definitely something to think about.
Interesting. Yeah, I mean that makes sense. That I've run into more problems with my validations getting out of control much faster than things like attributes. So it makes sense to focus there. I wonder if it'd be possible, and I should get off my butt and actually maybe just open up an issue or a pull request to Ecto and see if this is possible. But it seems like maybe somewhere in the change set struct you could have a virtual attributes place where you could stick like, oh, I'm expecting this password of type string, and then that could allow the coercions and things like that to still happen. But I'll get off my duff and actually go try to contribute something instead.
Yeah. Well, and the other thing too, that when your Ecto schema, the tricky thing of this is the Ecto schema becomes a struct on the model. So we take all those fields, and that's what lets you say user.password in your code. So if those were suddenly dependent, or if those were suddenly dynamic, we no longer could have a single like user struct, because that's fixed at compile time. We could return a map. The map could have dynamic keys, but since we have fixed keys, you'd have some places in your code that would want to say user.password and some that would blow up if you tried that. But then at the same time, those couldn't be the same struct. So I think from a current implementation point of view, it's got to expand to an individual struct on the model. But Ecto does allow you to define. You could define a separate model with the virtual attributes, and it still would use the same schema, and that would actually be totally fine. So theoretically, you could define a separate model entirely that uses the same schema and same database. But yeah, so there is a limitation there.
Interesting.
So
Yeah.
I was just thinking, what about like on the connection struct where it has a spot for the person to add anything they want, like through assigns or something like that? Because maybe the user model, instead of specifying virtuals there, you can compose it in the change set to say, on this model, here's my specific things inside my assigns or my virtuals, and so you can say virtuals.password or something. And so then you have fixed keys for all of the attributes, and that doesn't change, but then you have a specific case where you can handle the dynamic fields on the model.
And maybe you could, instead of accessing it using like the access protocol with dots, you could have a helper function that's like, oh, change set, get this virtual attribute back out of the change set, and it would know how to reach into the right part of that struct or something like that. But it does seem like it would be quite a bit more clunky than all of the other attributes that you're dealing with. And so it would make like writing your form helpers and stuff, it would make that a bit more clunky than it is right now. So I'm not sure if that trade-off is worth it, but something maybe we can try out.
And I also think it's a good point where you said, like, if you are running into a problem where you have tons and tons and tons of virtual attributes, like perhaps there are bigger problems than the composition of virtual attributes or something.
Yep. So I would say, yeah, for now I wouldn't worry about it. And I mean, you get them for free. So like even if you had a bunch of virtual attributes, like he showed me a specific use case. Like I like to tell everyone, like whenever I like close an issue on Phoenix, I always say like I remain unconvinced that we need to do this, but that doesn't mean that I can't be convinced. So if you showed me a model and you were like, this code is just really bad with all these virtual attributes, and I couldn't think of a better way to do it, then I'd be open to it. But yeah, it seems like it's just a key on the struct. If we add a bunch of them, it doesn't cost us anything. So there are bigger things to take on right now.
Cool. Anyone else have a question before I monopolize more time here? All right. So another one, obviously there's been all the Phoenix channels benchmarking going on these days. We talked just before we started the recording tonight about that Chris is actually lacking sleep because he's been staying up doing all that. But one question I had there, kind of two questions that go back, kind of go together. I was wondering if you could give a little bit of insight into how the pub sub part of channels works. Like what is, it's kind of a detail that it seems like the guides for channels try to kind of just go over that and say you can use many different kinds of pub subs, but I didn't get a good idea of how the pub sub fits into the channel. So maybe if you can give us like one layer of abstraction below the public interface to channels, so I have a little more idea of how that's working. And part of the reason I'm wondering that is because a use case that I'm looking at from work right now is we would have many, many channels with few consumers inside of each channel. So the channel would end up being like data for a specific user, and that user might have between 1 and 5 sessions would be a very normal number of WebSockets that would actually be connected and consuming messages off of that channel. And so I'm wondering how does the scaling look for many, many channels with relatively few consumers in them as opposed to the benchmarking of one giant channel with many, many consumers?
Yeah, so I'll answer the second part of your question first. So it actually, the use case of lots of consumers on many different topics is actually way easier on the server. So your use case is going to perform way better than having everyone join a single topic. So basically, our goal, it was a specific benchmark we were testing. So we had 2 million people all joining the room's lobby topic. So we had 2 million subscribers on one topic, which isn't a real use case. It could be a real use case. I don't know. I'm thinking like a power company could say, everyone in the city or this state, like all your dishwashers and washing machines and ACs, like cycle your power down, right? If there's a power surge. So technically that could be a use case. But anyway, the most often use case is you're going to have many different users, and those users are going to be subscribed to different topics, but your number of subscriptions on a single topic are going to be relatively low. Like a chat room is going to have, maybe a couple hundred people max. Like most use cases are going to be what you've described, and those are going to perform better only because to broadcast you only have to walk a list of dozens instead of a list of 2 million, and you only have to send dozens of messages instead of 2 million messages. So the benchmarks we did, every time you typed the message in the chat room, that would have to send that message to 2 million people, which is a lot, but it handled it in like 2 seconds, which is kind of blew me away. But to answer the first part of your question with PubSub, we shield that intentionally because most people are going to be operating one level up. Channels is built on top of PubSub, and you very rarely need to dip down into PubSub. The PubSub module is just a generic publisher to subscribe system where you can just subscribe to some string topic and you can broadcast any arbitrary Elixir term, and then anyone listening on it will get that Elixir message. And then channels is built on top of that, and when you broadcast in your channel, you say like broadcast socket, new message. That payload is actually a special broadcast struct. So we're kind of one level up. We're built on top of PubSub, and you can it's a little bit more restrictive, but it matches this kind of client-server scenario. So yeah, I mean, I could talk about PubSub for a long time because I just was in this space. So do you want to know like design specifics of how like the PubSub actually works internally, like how it's distributed?
Yeah, I have just a couple of specific questions off the top of my head.
Okay.
So, when you were doing the benchmarking, were you using the Redis adapter, Postgres, or RabbitMQ? I think those are the three that I saw were supported.
No, so just standard library. In fact, the Redis, any of those other ones are going to perform much worse, I'd say. And so if you can avoid it, if you can avoid using Redis or any of the others, definitely do it because we get, I mean, Erlang has the distribution model already. So what we do out of the box, if you're using the PG2 adapter, PG2 is a part of the Erlang standard library. It's basically distributed process groups. So I can say, hey, this process is going to join the group foobar, and then it's going to distribute those processes across the cluster for you. So any processes you put into that named group can see everyone else for free, like magic. You don't have to write any of that orchestration. So what we do is if you're on one node, we keep a local list of subscribers. So if I'm on chat room 1, on node A, I'll have a list of subscribers on that node, and when I broadcast a message, let's say it's going to 10 users on node A, I'll look up all the local users on this node, I'll send a message to them, and then I'll broadcast a single message to the PG2 group, and that has a process that then will broker that message across the cluster. So it will only send one message across the cluster saying, hey, this local PubSub server needs to notify everyone on room 1 that this message is here. So it's going to just distribute really well, and it's not going to, like for the 2 million subscriber case is a good example. For 2 million subscribers, let's say that was on one server. Let's say we had 2 servers, and we had 1 million on each of them. And they're all on the room's lobby topic. If I broadcasted from node A a new message, it would go to 1 million people on node A, and then the pub subsystem would send one message across the cluster on PG2 saying, hey, notify everyone on room 1, here's the message. And then that one message that went across the cluster would then go to the 1 million users on the second node. That makes sense. We're not sending 1 million messages across we're not sending 1 million messages to everyone on the cluster. It's like it's brokered across by a single process. And that's handled by PG2. So if you look up the Erlang documentation, PG2 is pretty simple, and it's very easy to build a distributed PubSub on top of it, and it's super fast.
Yes, for good standard libraries. Yeah, I was totally confused. I just saw the name PG2 and assumed that was Postgres because there's a bunch of adapters in Rails land called PG2. Because I guess the original Postgres adapters were terrible or something.
Yeah, it's process groups. There's a PG. Phoenix PubSub used to be on the PG module in Erlang, but then that's deprecated, and PG2 is its replacement. So they didn't know what else to name it, I guess. So PG2 is just the new version of distributed process groups.
Sweet. All right. So basically, as long as you can get your nodes, as long as they're kind of like network adjacent and they can join a cluster together, then that's going to be probably the preferred method of managing your channels.
Absolutely, because you don't have to, I mean, from an operational perspective, it's way easier, and then you're not having to shove, I mean, it's basically the problem that other languages have, like if you have like Socket.io and Node or Action Cable with Rails and Ruby, you have this inter-process communication thing, and it's going to be way more expensive to funnel messages through that. It's like we have the standard library. It has distribution baked in, so like the message format of the Erlang distribution has been optimized for you. So I would be totally shocked to see anything perform better than what we have in the standard library. In fact, like you could go with RabbitMQ, but that's based on Erlang, so they're probably using the same stuff in turn. You know what I mean? So it's like I don't think from an operations perspective, if you already have RabbitMQ, it might make sense, but out of the box, it should be pretty great.
Okay, that totally clears up all of my questions, yeah. Because I was going to ask, I mean, I actually use RabbitMQ quite a bit at work right now, and we have a bunch of Ruby libraries that try to make it look and feel very idiomatic to be subscribing to things and use the common naming convention. But yeah, getting 2 million messages through a RabbitMQ broker and back out to a bunch of consumers, I was like, I don't think you can do that in 2 seconds on one box. Like, we have a pretty good sized rabbit cluster, and it doesn't do 2 million messages a second. Definitely not close to that. So yeah, that makes sense that you're just using internals to Erlang Standard Library. All right, well, that totally answers my question, and that alone was worth having you on because that definitely gives me a path forward for my project. Anyone else have questions that they want to ask Chris before we wrap up for tonight? All right, let's then just go around the horn and name one cool thing you learned about this week. And Chris, why don't you start us off?
One thing. Okay, so I learned a few things with the PubSub bottleneck. So one thing is, like, if you're everyone familiar with timer send interval, you can say timer.send interval and send yourself a message every 5 seconds, right?
Yeah.
I was doing that on the WebSocket transport for channels to say every 30 seconds send a heartbeat from the server to the client. And that ended up being one of our bottlenecks that we found. And we were hitting a bottleneck and couldn't figure out why. Like most of the bottlenecks were in PubSub, not at the transport or channel layer. And we were at like why, what is going on? There's like the system was just behaving slower than it should have. But the cores were only at 30% CPU usage. So there's some contention somewhere, but the VM basically was had no work to do. So anyway, I fired up Observer and sorted by message queue size. Like you could sort by show me the processes whose mailboxes are queuing up with a bunch of messages. That means like so many messages are arriving they can't process them. And it turns out there's a timer server. And like I should have known this, but there's a timer server in Erlang that when you call timer send interval, that's actually another server, and that server is going to be the one that tries to send you messages on that specific interval. So we were bottlenecking the Erlang timer server by using timer send interval. So the workaround was use process send after, and process send after is using a different timer. That actually we're optimizing Erlang 18. It's not using a server. It's like a built-in function beyond my level of understanding. It's a timer, but it's just going to call. It's going to send you a message later, but it's not using a central process. So you lose some of the delivery precision. So I think the timer server is supposed to be more precise, like definitely every 5 seconds as close as possible. So instead of using timer send interval, we said process send after 5 seconds, do a heartbeat, and then within the heartbeat message, we then would just do another process send after. So instead of send interval, it was just send after, and then when you handle that, send after again, and you could do that. You could do an interval that way, and it was way more efficient. So that was a pretty cool thing to learn. So if it doesn't mean don't use timer send interval, but if you're using timer send interval, realize that that's going to be sending a message to another process, and that could end up being a bottleneck in your system.
Sweet. Anyway, it just makes me wonder. I was working on a Nerves project the other day, and I was using in a gen server. You can have like the timeout thing, and I think that's just doing like it just does after this many milliseconds on your receive loop, which is kind of the way I got around that, just because my gen servers happen to be so close to idle that the precision didn't matter. But anyway, that's very interesting. Dave, do you want to go next?
Yeah. Okay. So I'm gonna share what I thought was cool. All right. So minimize that. Okay. So what I thought was cool. So I'm in Windows land, and I know I don't get a lot of support or love from lots of cool stuff that I like to play around with. But so when in this chapter, when we're using the come on in plug, or not plug, whatever it is. Sorry, don't know the right terminology. And I ran like Mix Phoenix server, and I got this error message, and it's like, hey, you can't compile this because you couldn't find nmake. well, you just need to do this stuff. And I was like blown away that the longest thing, the hardest thing that I had from this whole process was waiting for Visual Studio to install so that I could use the developer command prompt. That was it. Everything else, it worked just like super well. And then it's like, oh, and maybe if you're using 64-bit Erlang, you might have to do this. And if you're doing this, you also should probably look at getting the C++ language tools installed. And it just worked. I loved it. It was so awesome. I love that that about Elixir and Phoenix. Is just so even though I was let me stop my screen share. Oh, how do I do it? Oh, good. Okay, so just that I'm so used to, hey, there's this new cool tool, language, framework, whatever. Well, it probably won't work on Windows, but I'll give it a shot. And I've been blown away by the amount of support that I've found for Windows, and just the error messages, and like that was very specific to Windows. Like you need Visual Studio, you need to run these things in these particular places. So it's been really, really neat to see that. About the only problem I've had has been not being able to use the link helper inside of a template with method of delete, like for whatever reason. I don't know what's going on, but that's about the only thing. And that's like easy workaround with a button because I'm just learning it right now, so I'm not as caring about it. I don't care if it's a link or a button. But other than that, it's been, wow, blown away. I love it. I love it that I'm very close to a first class in Windows land with Elixir and Phoenix.
I was going to say, I'll interrupt here. That's awesome. So Windows is definitely first class, but I think so. Jose and I don't have Windows boxes, so we want to support Windows as much as possible, and we want everyone to have a first class experience. The biggest issue we have right now is actually Node.js, which is what your link issue is. So like the biggest issue we have on Windows is not even our fault. It's like Node.js and Brunch have issues on Windows, and that's like one of our biggest source of GitHub issues. It's people having problems with Node on Windows. So that was just my rant against Node. But if you're having problems, we definitely want to support Windows just as well as anything else. So open an issue, and I'll track down that Brunch or that delete thing that you're having. Someone else opened an issue today on it, so we'll get that sorted out.
Yeah, that's awesome. That makes me feel good. I've definitely experienced I'm a second-class citizen with Node, so that totally makes sense. But yep.
Sweet. Garrett, do you want to go next?
Sure, I'll go. I think I'll be quick too. I think one of the coolest things was just the composition of pipelines. Just simple functional composition. Pipelines work super well. It's just, I won't say the word middleware, but something like that in Ruby land, an analogous pattern. I just wish I had the same power. I just wish pipelines were a thing in Rails, because that would make my life so nice. That's it.
Sweet. John, you're up.
Mine was a little bit simpler. Before I had really finished the chapter, I was starting to get into my own side project, and it was really going back to more of a RESTful use of. I wanted to utilize Phoenix more as a RESTful, give and take of data release. And get responses back for that. And I had tried a little bit and dabbled, and it wasn't working. I hadn't gotten it. Then I started going through the chapter, and at the end of the chapter, it says for the next chapter and the wrapping up that they'll start using code generators to speed things along. And my past experience with code generators was, sometimes it may get a good amount of code to start, but it makes things very brittle if you don't go through and essentially change most of it. but I decided to look to see if I found anything for what I was trying to accomplish, and there's actually this Phoenix Gen JSON code generator, and I did that and made a controller, the model. You give it the name of the model, and you even give it the fields that you want in the schema, and it built that all. All I had to do was just add a route, and it even had most route stuff in there as well. And in 5 minutes, I had this nice structure of simplistic RESTful code, and could make just simple curl requests and get data back, and write to the database and get it back. I mean, there's obviously a lot that you would change to customize it, but it was nice, or actually it was kind of depressing to see like the hour I had spent the day before was solved within 2 minutes of running a simple command to generate a lot of that to start off of to begin with. So now I have a really good, strong path to go forward to get JSON responses back to finish out some of my other project that I have going on.
Cool.
That's
Zach, you're up.
awesome. Well, I'm going to interrupt again just because we debated whether or not to show generators earlier in the book, and just because it was like, what, you made me write all that time. But yeah, it's like we wanted to make sure that folks kind of knew the internals before leaning on generators right away. So that's why, yeah, so sorry, but it'd be worth it now that you've gotten this far.
It's actually useful generator, and I actually did have that thought when I ran the generator and I started looking back at it. I thought I wrote almost this exact, definitions in these exact modules. What the heck? But I was happy. It's good to go through it.
Yeah, on I think it was actually the first week we met. That was one of kind of the group's big call-outs, is that we, as book readers, really appreciated seeing one level of abstraction below the generators early on, and especially for things like authentication. That's the kind of stuff. I mean, it's little details like, oh, I'm going to issue this session and I want to reset the session. That's something I have to think about all the time as someone developing an actual API. And it's so hard to find that kind of stuff if you're starting off with generators. So I still haven't actually run any of the generators on any of my Phoenix projects. So I guess next chapter should be fun for me. So Zach, I guess you're up next.
Sure. I found a great article by Michael Muscala. Don't know who that is, but he wrote this blog post on like understanding lists in Elixir, and it was great. And I was thinking about my exorcism IO, the list operations that I was doing, and it's like, oh, he explains tail call optimization and why you are going to pass an account so that you can optimize that. I was like, I could optimize probably that entire exorcism IO, every single stage you build. I was like, oh, I'm pretty sure I could go back. And some of my that I had to rethink. So it was a great article on understanding like the internals of how Erlang and Elixir treat lists, and like how the head and tail, that type of stuff works, and tail recursion, things like that. So it was a lot of fun. Maybe I'll just share that in Slack or something, but that's what I'll share.
Awesome. Yeah, just post the link to that in the Slack group, and then I'll put it on the video notes as well. Awesome. So the main thing I played around with this week is I tried to build a Nerves project a while ago, and it had run into some roadblocks early on, and I just wanted to give a shout out to people running the Nerves project. They've had a really big push on it again, and they're really focusing their support specifically around Elixir at this point. Originally, it was mostly focused around Erlang, and Elixir was also supported, but that's where I had run into a few of my issues, was trying to get past a few Elixir edge cases, and they've now kind of focused their support on the Elixir language. That's kind of the main thing that gets called out on their homepage and things like that. So it's been a lot of fun. I'm going back through, and there's a good talk at ElixirConf this year about this one company that uses the Nerves project, and the reason they started using it is because they built just like a little demo product, and they let it sit and run for a month, and after a month of sitting there and like dealing with network traffic and doing all this stuff, it had a completely flat memory usage and almost totally idle CPUs after like a month. And anyone who's been in object-oriented land on Rails stuff or Java stuff, I'm sure that sounds almost ridiculous, because it's very common practice in those other communities, as far as I've been involved, to do things like just have a cron job kill your server so that it gets restarted, so that you don't just eat all the memory on the whole machine. And trying to track down things like memory leaks can be a huge issue. And in my own experience, even before I was using Nerves, I built a little alarm clock for my son. I have a 4-year-old, and he couldn't read a clock, so he was always coming downstairs at 5 a.m. And so we built this little Raspberry Pi alarm clock that just turns on lights when it's the right time to come downstairs. That's how he knows when it's time to come down, and that's how I can get an extra hour of sleep in the morning. So it means a lot to me that alarm clock doesn't crash. And just putting together a really simple Elixir project, it sat and ran on that Raspberry Pi for multiple months, and he like plugs it in and out of the wall all the time and messes around with it. And so like everything that could have gone wrong with it pretty much did, except it never crashed. It just kept on running. And so for me, as a kind of an embedded systems enthusiast, that looks really, really promising. So a big shout out to the Nerves people, and I'll post a link to their homepage in the video notes as well. So thanks to everyone who was on the call tonight. Big thanks to Chris for being willing to jump on and hang out with us and answer a bunch of our questions. And I think we'll call it a night. Thanks, guys.
Thanks.
Thank you.
And thanks, Chris.
Night.
Yep.